understand this coordinate geometry. I think in your high school days you might have come across coordinate geometry, as graph paper is something what you all are familiar with. So putting it in a nutshell, coordinate geometry is all about graph paper based geometry. I am sure we all know that graph paper is made of two lines. One is the basic horizontal line, we call it as x-axis, and then we have a vertical line called as y-axis. We have some simple conventions that points, if you look at x-axis, points on the right is taken as plus, points on the left is taken as minus, points above is taken as plus and below is taken as minus. Right plus, left minus, up is plus, down is minus. With these sign conventions, the basic plotting is being done. Now, this graph paper, as you see 4 segments there, as quadrant 1, quadrant 2, quadrant 3, quadrant 4. These 4 constitutes the entire graph paper. You could see that quadrant 1 is right as well as top, x greater than 0, y greater than 0. Right, top, both are positive signs. Quadrant 2 is left and top, x is negative, y is positive, left top. If you look at quadrant 3, left bottom, both are negative signs. And quadrant 4 is right as well as bottom, so plus minus. These are the basic sign conventions adapted. Let's start learning how to plot the points in the graph paper. So everything has to have a start. So the originating point is what is called as origin. We take it as the point of intersection of these two lines. Where we mention 0, we give the coordinates as 0. So to have the coordinates, we need to have two inputs. One is the x, other is a y. X is a horizontal component, y is the vertical component. Let us look at some points and see and try and locate them in the graph paper. So as we saw, the point of intersection of two lines is where is this originating point. Suppose you look at a point called phi negative 4. Here you see x is positive, y is negative. Phi negative 4 would be in fourth quadrant or quadrant 4. Then look at negative phi 2. Negative phi 2 is x is negative, y is positive, so it should be in quadrant 2. Look at the next case, negative 2, negative 4. Both are negative, it should be in quadrant 3. If you look at 1, 2, it's in quadrant 1. Whereas if you look at 10, 0, it is very much on the positive x-axis. Likewise, if you look at say 0, 10, 0, 10 should be in positive y-axis. So we have learned how to plot the points in the graph paper. And we all can appreciate that the most fundamental unit in geometry is point. So we have learned how to give an address or how to locate a point or how to plot the point, and also we are able to give its coordinates. That's what, the geometry pertaining to it is what is coordinate geometry. So we have just started with coordinate geometry. With one point, we only have two things. One is what is a point and where is the point. We have learned that. Okay, if 2 points are given to us, I don't think we'll keep quiet. We want to know how much near the 2 points are or how much far the 2 points are. Basically, we need a metric to know how much near the 2 points are or how much far the 2 points are. Well, this metric is what is called as distance between 2 points. In fact, we have a formula for computing this distance between 2 points. So here goes the formula. If x1, y1, x2, y2 are 2 points, let's denote it as a and b. The distance between them is given by d equals root of x2 minus x1 the square plus y2 minus y1 the square. The entire thing under the square root. Okay, life is better if we have an example for this. Let's look at this. Suppose the 2 points given to us are 7, 9 and 10, 13. One point is 7, 9, the other point is 10, 13. So you can clearly see x1 is 7, y1 is 9, x2 is 10, y2 is 13. So we just have to put these numbers or plug these numbers in the formula. x2 minus x1 the square. So you have 10 minus 7 the square plus 13 minus 9 the square. So 10 minus 7 is 3. So 3 square plus 4 square is nothing but 9 plus 16 is 25. The square root of 25 is 5. This means the distance between the 2 points is 5 units. So you all might be wondering, what's the big deal? So what will happen if I know how to compute distance between 2 points? Look, there are a lot of things that can happen if you know how to compute distance between 2 points. In fact, how do you discriminate 2 circles, tell me? You discriminate 2 circles on the virtue of size, on the basis of size. You say small circle and big circle. What makes a circle small? Shall we say it is a radius? Yes. If you know how to compute distance between 2 points, if you know, you can discriminate the circles. So it's basically radius. What is radius of a circle? Radius of a circle is nothing but distance between the center of the circle and any point on the circumference of the circle. So we all know there are three types of triangles. So scalene, isosceles and equilateral. Suppose you want to check whether a triangle is equilateral or not. So if you look at triangle ABC, say if you want to know ABC is equilateral or not, you say AB equal to EC, which means what? You are equating the length of the side. What do you mean by length of the side? Distance between A and B. If you know how to compute distance between 2 points, you can identify what type of triangle it is, number one. You can also discriminate or distinguish different types of geometric figures. And apart from this, we can also answer a very interesting question. If you know the coordinates of two adjacent sides of a square, the distance between them would give us the length of the side. Wow, once you know the length of the side, you have three questions that can be answered instantly. One is, you can find the area of the square, you can find the perimeter of the square, you can find the length of the diagonal of the square. Likewise, if you know all the four corners of the rectangle, I'm sure, in fact, you can even find what is called as, you can find the length, breadth. Once you know length and breadth, you can find the area, you can find the perimeter. So it's all about distance. Apart from this, if you also know three coordinates, the coordinates of 3 points that makes a triangle, you can find the length of each side. Now once you know the length of each side, there is a great formula, Hero's formula, which is root s minus a, s minus b into s minus c, which is a typical example that you come across in pure geometry. Now life is not that bad if you have to find the area of a triangle. In fact, the next thing what we will look at is distance formula is just, it's able to give us the length of each side. Now the next thing what we would learn is how to find the area of a triangle. So with 2 points you have distance, now we go ahead with 3 points. With 3 points you can form a triangle. We will learn how to find the area of the triangle. Of course we can still use distance formula to find the length of each side. As I mentioned, you can apply Hero's formula and go ahead. But life is not that bad. We have another way of finding area of triangle formed by 3 points. Suppose the 3 points are x1, y1, x2, y2 and x3, y3. The area of triangle formed by these 3 points, we have this formula, half x1 minus x2, y1 minus y2, x2 minus x3, y2 minus y3. Now just don't get scared about these symbols. It just follows a cross rule, like. So if you want to compute this determinant, this is called determinant of a 2 by 2 matrix. We will demonstrate this determinant through an example. Say if you want to find the area of the triangle formed by 17, 7, 3, 5 and 1, 1. Suppose these are the 3 points. You want to find the area of the triangle. First thing is half 17 minus 3, 7 minus 5, 3 minus 1 and 5 minus 1. x1 minus x2, y1 minus y2, x2 minus x3, y2 minus y3. That's precisely what we have done. Now 17 minus 3 is 14 and 7 minus 5 is 2 and 3 minus 1 is 2, 5 minus 1 is 4. Now all you have to do is 14 into 4, just have to look at the cross tick. 14 into 4 is 56, 2 into 2 is 4. 56 minus 4 is how much? 52. 52 upon 2 is what is? The area, okay. So 26 square units would be the area of this triangle. In fact, once you know how to give it, once you know the 3 points of forming once you got a value here, it's not only helping us to find out the area of the triangle, it can also give us another interesting thing, that given 3 points, if this quantity what you got here, now that it is 26, that means area is enclosed by this. There are occasions where this determinant value would become 0. In which case we say these 3 points are not forming a triangle. So given 3 points, intuitively we all know that either they form a triangle or they form a line. Now if this determinant value is coming as a non-zero quantity, then that non-zero quantity is what is area of this, it's what is area of this triangle. In case you get it as 0, that means the 3 points are collinear. We can also find one more thing. We will do one thing. If 3 points are given to us, let's check whether they are collinear or not. Collinear means sharing the same line or lying on the same line. Let's take for instance 3 points. The 3 points are 7, 5, 3, 7 and 5, 6. These are the 3 points. We want to check whether these 3 points are collinear or not. So let's plug these things 7, 5, 3, 7 and 5, 6 in the formula. The first thing is 7 minus 3 and then 5 minus 7. Then you have 3 minus 5 and 7 minus 6. Now if you compute the determinant the way we did it there, you get it as 0. Yes, this simply means that the 3 points are collinear. As we saw, that if the determinant is non-zero quantity, then it's forming a triangle with that non-zero quantity as an area. And in case the determinant value is 0, it simply means that these 3 points are collinear. Let's come to the next important thing. If 2 points are given to us, we have learned how to find the distance between the 2 points. So if 2 points are given to us, it's quite interesting to know what is in the exact middle of this. In fact, the formula to find the coordinates of midpoint of the line segment joining 2 points is x1 plus x2 upon 2 and y1 plus y2 upon 2. If you are asked to find the midpoint of the line segment joining 5, 7 and 3, 1. So 5 plus t is 8, 8 upon 2 is 4 and 7 plus 1 is 8 upon 2 is 4. So 4, 4 is the midpoint of the line segment joining these 2 points. I am sure you all can appreciate the midpoint formula as average of x coordinates and average of y coordinates. And what a nice name given to this. Mid has got something to do with middle. So middle means average of x coordinates and average of y coordinates. Okay, a little bit of interesting vocabulary is what you saw here in naming it as midpoint of line segment joining 2 points. Let's not forget that midpoint can be appreciated as center of a circle whose diametrical ends are given to us. So if you know the ends of diameter of a circle, the midpoint of the diameter is nothing but the center of the circle. In other words, if you also know the ends of diagonal of, let's say, a parallelogram, if you know the ends of diagonal of a parallelogram, you can find the midpoint of one diagonal. The midpoint of one diagonal will be same as midpoint of another diagonal because the diagonals share the midpoints, or diagonals bisect each other in a parallelogram. That means finding midpoint of one diagonal is same as finding midpoint of other diagonal. So midpoint has got these simple applications. Let's now come for what is called as line. So we all know the moment you see the graph paper, your eyes can't miss these 2 lines. One is the x-axis, the basic horizontal line, and what is common about any point on x-axis? Y is 0. What the relation satisfied by every point on x-axis is y equal to 0. What is the phenomena of x-axis? Y coordinate being 0 is a phenomena of x-axis. Instead of calling it phenomena, which sounds more like natural science, let's look at it as mathematics. Mathematically, it's just a relation where y equal to 0. It's an equation there. The relation is y equal to 0 is what is the equation of x-axis. Likewise, if you look at y-axis, a vertical line, you see that x is 0 for any point on y-axis. So x equal to 0 will be the equation of y-axis. Okay, having discussed x-axis and y-axis, let's look at a horizontal line. A horizontal line is nothing but a line parallel to x-axis. A line parallel to x-axis is what is horizontal line. So any line parallel to x-axis, y will be constant. Y equal to 0 is x-axis. Anything parallel to it is y equal to constant. Likewise, if you look at a vertical line up and down, so that's a vertical line, you see that x is constant on a line which is parallel to any vertical line, x is constant. Any horizontal line, y is constant. That's it. If a line is neither vertical nor horizontal, what else could be the line? If not horizontal, if not vertical, it has to be an inclined line. So we have got a sample inclined line on the sheet there. You could see that x and the third most prominent line on the x-axis, I am sure you wouldn't disagree with me that it is the line y equal to x. So let's do one thing. Let's apply this in some examples.